In this section, we'll start a new example that will show you a number of GraphQL features. The application is a job board, and I'm providing you with an initial project that already contains some server functionality and a front-end application. This way, we can focus on adding GraphQL support without having to spend a huge amount of time creating all the user interface and other stuff that has nothing to do with GraphQL. The server is based on Express, which is a popular framework for node.js, while the frontend uses React and was initially generated with the Create React App tool. If you want to follow along, please go and get the initial project from this page, that is github.com/app2skill/graphql-job-board. Then you can click on the clone or download button and either download a zip archive, or if you're familiar with Git, copy the repository location from here. I'm going to use a terminal and keep this project under my projects GraphQL folder. Then do git clone, paste the repository URL, and optionally you can specify a folder name. I'll call it just job board. Once it's done, we can go into the repository folder, and it contains two subfolders called client and server. These are like two separate projects, even though they're in the same repository. Let's open the server project first. I'm using Visual Studio Code as my usual. There's a package.json file here that lists some dependencies like Express. So let's go and install those dependencies. In the terminal, let's run npm install and wait a few seconds. Once it's done installing packages, we can go and have a look at server.js. This file contains most of the server code. Again, this is an Express application, and it only exposes this login endpoint that we'll talk about in more detail later. Note that there is nothing using GraphQL here yet. We will add all the GraphQL functionality as part of this exercise. Now let's go and start this server by running npm start. And you can see that the server is running locally on port 9000. Next, let's go and open the client project as well. Here you go. Again, there is a package.json file with a few dependencies, including React. Let's go and install them using npm install again. This will take a little while. All done. At this point, we can have a look at the source folder. You can see that it already contains a number of files. Let's open app.js that contains the top-level component. This is a React component, a class component in fact, and if we look at its render method, this is what creates the user interface. Note that it uses React Router, so it will display a different component based on the URL path. Let's go and start this application so we can see what it looks like. Again, we can run npm start. This will launch the app using the development server and open it in the browser automatically. You can see that it runs on port 3000 by default. So this is the user interface. This page shows the job board component that simply displays a list of jobs. If we go back to our code, you can see that the slash path, that is the index page if you like, uses a component called job board. Let's have a look at that component. This is another React component, and it displays a job list passing some jobs, that is the data to display. And this jobs data comes from a file called fake data. If we go and open that file, you can see that it just contains some hard-coded dummy data. For example, here's the jobs array, and its first element is an object with job1 as the title, which is the same data we saw on the web page. So at the moment, the front end is just displaying this hard-coded fake data, is not calling the server to fetch the data, at least not yet. It will be our task as part of this exercise to get the data from the server by making GraphQL queries. Now let's look at some other pages. If you click on a job, you'll see a page showing the details for that job. And if you notice, the URL has changed. The path is now /jobs/job1. If we go back to the editor and look at app.js again, the URL matches this route with path jobs/jobid and will display the component called job detail. I won't show you the code for each and every component now. We'll do that gradually in the rest of this section as we modify the functionality. Right now, I just want to give you a quick overview. If we click on the company name, we see another page with the company details. And again, this page will have its own separate URL for routing. Then there is a login link in the navigation bar. Now, the login is the only piece of functionality that already calls the server because it doesn't use GraphQL. Here we need to enter an email and a password. So let me show you where to find them. If we go back to our server project, we mentioned that there is a login route here. What this code does is it gets email and password from the request, finds the user with that email from a DB, checks if the user exists and the password matches, and if so, it returns an access token following the JSON Web Token standard. Now, the DB used by this application is a very simple database that stores everything in JSON files under this data folder. In a real-world application, you'd probably use something like MySQL or Postgres or MongoDB, but to keep things simple for this example, we keep all the data in these local JSON files. This way, you don't have to install and configure a separate database, and it's also very easy to look at the data. So if we look at users.json, you can see that it contains two users in the form of two JSON objects. Each user has an email and a password, and in fact, these are the credentials that we can use to log in the front end. Let me copy this email and paste it into the form, alice@faceschool.io. And the password is alice123. With this, we should be able to log in and we're sent back to the home page. But if you notice, the navigation bar has changed. Instead of login, now there's a logout link. And there's also the option to post a job. This takes us to a form where we can add a new job. We can enter a title and a description, click submit, and not much happens at the moment because here we should call the GraphQL server, but that's not implemented yet. However, if we open the developer tools, you can see a message saying should post a new job. Anyway, that's the new job form. The last thing we can do is click logout, which does exactly what you'd expect. So this was a quick overview of the project we'll be working on. We already have most of the front end, all the components to display the data. What we need to do is expose a GraphQL API from the server and then call it from the front end, replacing this fake data it's using at the moment. We'll start in the next video. Now that we had a first look at our job board application, it's time to start making changes so that we can fetch the data from the server using GraphQL. The first step is to add GraphQL support to our server, and we'll do that using Apollo Server, the same library we used in our first example. However, in this case, we're not starting from scratch. We have an existing Express application, so we'll see how we can add Apollo Server to a project using Express. Let's go back to our server code. As we said, there are no GraphQL dependencies yet in this project. So let's go and install some. Let's run npm install and we want the Apollo Server Express package. Note that it's not just Apollo Server like in our Hello World example, but Apollo Server Express because we're working with an Express application. And then we need the GraphQL package as well. Now that we have our GraphQL dependencies installed, let's go and modify the code in server.js. For a start, we need to import some things from Apollo Server Express. We want the Apollo Server class, and then the GQL function that, if you remember, we can use to parse a GraphQL schema. Now we can create our type definitions by using the GQL tag function, but I'll just add a to-do comment for now, and we'll come back to the schema later. Then we need a resolvers object, and again I'll leave it as a to-do for the moment. I want to get all the pieces wired up first, and then we'll flesh out the details later. Now we can create a new Apollo Server instance, passing a configuration object with our type defs and resolvers. So far, it's exactly the same thing we did in our Hello World example, but here's the difference. Now we need to plug Apollo Server into our existing Express application. We do that by calling the apply middleware method, and here we pass an object with our app. Just to be clear, this is the Express app defined above. Optionally, we can also set a path, that is where we want to expose the GraphQL endpoint on our server. This defaults to /GraphQL, but I prefer setting it explicitly so it's clearer when you look at the code. This is the basic setup for using Apollo Server with Express. Now let's go back to our type defs. We could write our schema here, like we did in our first example, but I don't really like the idea of writing a lot of code all in this file. So this time I'm going to create a separate file and call it schema.graphql. The .graphql extension makes it clear that it contains GraphQL code. So let's write our schema in this file, starting with a type query as always. Now here we should add queries that returned data used by our job board application, like a list of jobs, for example. But for a start, let's just add the same greeting query that we used in our first example. I just want to get to a point where we can start our server and make sure it works, then we can go back and improve the schema later. So here we now need to load our schema.graphql file. And to do that, I'm going to import the FS module that is one of the built-in node.js APIs. FS is short for file system. So instead of calling GQL with a template literal, here we can call it as a regular function and then use the fs read file sync function to read our schema.graphql file. We need to pass the encoding option and set it to UTF-8 to make sure it reads the file as a string and not as a binary file. So read file sync will return the contents of our schema.graphql file that will then be parsed by the GQL function and assigned to the typedefs variable. Next, let's think about our resolvers. Just like the schema, I'd like to keep the resolvers separately to split our code into smaller files. So let's add another file called resolvers.js. This is a regular JavaScript file. Now we're using node.js here, so each file is a module that follows the common JS format. This means we can use module.exports to export an object. This will be our resolvers object that we can import into the other file. Now we can define another object called query that will contain the query resolvers. And here we want a resolver function for our greeting field, where we can just return hello world initially. Again, just a minimum to get the server up and running. Finally, we can export the query object inside our module.exports object. This way, in our server.js file, we can replace the resolvers object literal and instead import our resolvers module using the node.js require function. We could even remove some empty lines now and keep these 4 lines together, the 4 lines that add GraphQL support. Good, now let's go and start our server and see if everything works. It's running fine, no errors in the logs. Now let's go and open the GraphQL playground. It should be accessible at localhost port 9000/GraphQL because that's the path we configured for Apollo server. Note that it's not running at the root path like in our first example. Let's write a query asking for our greeting. Let's submit it and we get our server response back. Great, everything is working. So we successfully added Apollo server to our Express application. The only difference compared to our first example is that we call apply middleware to integrate Apollo server into our Express app rather than running it as a standalone server. We also decided to keep the schema and the resolvers in separate files just to make our project more modular. In the next video, we'll see how to make our GraphQL server return a list of jobs. In the previous video, we added Apollo server to our project, and we created separate files for the GraphQL schema and the resolvers. We started with a simple greeting query just to test that the code we've written so far works. But a greeting is not really what we need for our job board application. What we really want is a list of jobs to display on this page. And what data do we need for a job? We can see that in this details page. Each job should have an ID that we use, for example, for navigation. It has a title, a company, and a description. So that's the data we'll need in order to display a list of jobs. Let's go back to our editor and see how we can declare the structure of that data as a GraphQL schema. First of all, we can define a new type called job. So in GraphQL, we can create our own custom types. We're not limited to the built-in ones like string. Once we have a job type, let's delete this greeting that's not needed. We want to be able to fetch some jobs. And this field is an array, which is denoted by square brackets like JavaScript arrays. And it's an array where each item is a type job. So this syntax means an array of jobs. Now, we haven't actually defined what a job looks like yet. Which fields does a job have? We certainly want an ID to uniquely identify each job. This is true in most cases. You'll want an ID for almost all your custom types. It's such a common requirement that GraphQL provides a built-in type for IDs, just like it has strings, booleans, and so on. The ID type is similar to a string. In fact, it is sent as a string in JSON. But using ID gives some extra information. It tells the client that this is a unique identifier, is not intended as a human-readable string. We can also specify that the ID should never be null by adding an exclamation mark. This strange syntax just means that each object of type job must have an ID. If we don't put the exclamation mark, then the field can be null, which effectively means it's an optional field. Okay, which other fields do we need? We want a title that is a string and a description that is also a string. Ideally, we should also add a field for the company, but we'll talk about that later. First, let's see how we can implement the functionality for what we have defined so far. We can remove the resolver function for greeting, and instead we want a resolver for jobs. This is a function, and what do we return here? We need to return an array of jobs. Let's start by just returning an empty array so that we can test if what we've done so far works. Let's save this file. If we look at our terminal, we should see that nodemon has automatically restarted our server. Now let's go to our graphical tool, delete the old query, and I'll also refresh the page so that it loads the new schema. Good. Now if we write a query, we can ask for jobs. Since jobs returns an array of job objects and each job has multiple fields, we also need to specify which fields we want inside curly braces. Let's say we want the ID, the title, and also the description. Why not? Let's request everything. If we execute this query, we get a response where jobs is an empty array, which is what we return from our server. So far, so good. Now let's go back to our editor and update our resolver function to return some actual data. This project already comes with this db.js file that is essentially our persistence layer. As I mentioned in the project overview, for this example we're not using a true database like MySQL or MongoDB. Instead, we save our data in local JSON files. This is not what you would use in a real application, of course, but that doesn't affect our GraphQL code. The basic operations you can do with any database are pretty similar. You can read items, create items, update items, and delete items. So you could easily replace this simple DB with some code that connects to MySQL or MongoDB or whatever. Now, to store data in JSON files, we use a package called NotARealDB that is a project that are written precisely for this sort of sample applications. It lets you create a collection for each object type you want to store, like jobs, and each collection is stored in its own JSON file. So jobs are saved in the jobs.json file, and here you can see all the jobs data. Currently, there are 3 items, where each item has an ID, company ID, title, and description. So we have some data ready to use. Now, how do we access that data from our resolvers? First of all, we want to import the DB module. Now, in response to the jobs query, instead of returning an empty array, we want to return an array of jobs from the DB. And we can do that by writing db.jobs, so access the jobs collection in the database. And on a collection, we can perform some operations like create, delete, etc. In this case, we want to list all the jobs. And that's it. This will return the array of jobs from the DB. Let's save this file and check if it works. In Graphical, we can simply run the same query again, and this time we get back some actual data. Great! So let's recap quickly what we've done in this video. We wrote a resolver function for our jobs query that returns the array of jobs from our database. And this is consistent with our schema, where we define a jobs field that is an array of job items, and each job has an ID, a title, and a description. The next thing we want to do is represent the fact that each job has a company associated with it. But before we do that, we'll have a more in-depth look at the structure of a query. Now that we have an initial implementation of the jobs query on the server, we can run this query and get back a data structure that's not particularly complex, but it's already more interesting than our first Hello World example. So I want to take a couple of minutes to explain queries in some more detail. One thing to notice is that we need to explicitly list all the fields we want to get back from the server. We cannot just ask for jobs and get all the data about jobs. We need to specify that we want ID, title, and description. If we don't mention a particular field, like if we remove the description and run the query again, you can see that the data returned from the server will only include ID and title for each job and not the description. This feature of GraphQL, where the client needs to explicitly declare which fields it wants, is to prevent overfetching, i.e. fetching too much data. If we're not going to display the description on the front end, then it's better not to request it. That way the response from the server is smaller, and that means less traffic over the network, and therefore our application should also be a bit faster. Specifying the fields in the query also means it's up to each client to decide what data it needs. Some clients can request the description and others may not. The GraphQL engine takes care of this for us. It will return only the requested fields. We don't need to do anything special in our server code. The other thing I wanted you to pay attention to is the way we nest objects and fields. To specify which fields we want on the objects returned by the jobs field, we put curly braces after jobs, and this is nested inside the curly braces that we have at the beginning of our query. These curly braces represent the root object, that is, the query itself. In fact, we can also write it explicitly. It's not necessary because it's the default, but we can write query at the beginning. And if we execute it, we get back exactly the same result. The structure of our query matches the structure of the schema defined on the server. We can see that clearly if we look at the Documentation Explorer. At the root of our schema, we always have the query object that is of type query. In this particular schema, the query type has a jobs field that is an array where each item is of type job. And the job type has these three fields, ID, title, and description. So inside the query object, we specify which query fields we want. In this case, we only have jobs at the moment. And inside jobs, we specify which job fields we want. Also note that when a field is an array, like in this case, the fields we specify here apply to each item in the array. Again, since query is the default root object, it's optional and we can leave it out for simplicity. So hopefully this gives you a better understanding of the structure of a query. We'll see more examples of different queries over the rest of the course. In our GraphQL schema, so far we have a job type and a jobs field on the query that returns an array of job objects. In the resolvers, we have a function to resolve the jobs by fetching them from our database that in this example will use the data found in the jobs.json file. So are we ready to call our server from the front end? Well, not quite. As you can see here, when we display the list of jobs, we also display the company name. And same thing in the job detail component. So we'll also need to return the company data from our GraphQL server. Let's look at the company details screen to see what fields we need for a company. Each company has an ID that we use for navigation, among other things. Then we have the name of the company and a description. So ID, name, and description are the fields we'll want to return from our GraphQL server. Let's go back to our editor and open schema.graphql. Here we can add a new type representing a company with the same fields we just said. That is an ID, which is a type ID and should not be null, just like for the job type. Then a name, that is a string, and a description that's also a string. So that's our company type defined. Now we can add a company field to job, and the type of this field is company. So in a custom type like job, we can use another custom type like company. That's the way we represent associations between different objects. Let's save the schema file and see how we can implement this association in the resolvers. Actually, let's see what happens if we don't change our resolvers. In the graphical tool, I'll reload everything so it gets the new schema. Then we can query jobs again with ID, title, and this time we can also get the company. Now, since a company is an object with fields, we need to specify which fields we want. Let's ask for the ID and the name, for example. Remember what we said in the previous video about nesting objects in the query. Now that a job has a company field, we have an additional level of nesting. Anyway, let's try and run this query. You can see that we get some data back, but since we didn't update our resolver, the company on each job is always null. So if the data returned by our resolver is missing a certain field, that will result in a null value being returned to the client. This is something that is good to keep in mind. Just because the server starts up successfully and returns some data, it doesn't necessarily mean that the data is what you expect. It's still up to you to write the correct code and test it, of course. So how can we return the company for each job? If we look at the jobs.json file that contains the database rows, if you like, each object in this array has a company ID. And each company ID matches the ID of a company in the companies.json file. So the company ID in the jobs collection is what you would call a foreign key in relational databases. We can use it as the reference to fetch the company object with the same ID. That's exactly what we'll do in our resolvers, because the job objects we get from the database have a company ID property, but what we declare in our schema is that each job object will have a company field that is a full company object, is not just a company ID. So back to our resolvers, how do we make this work in practice? Well, the resolvers must reflect the schema. Since in the schema company is a field of the job type, we need to declare a new resolver object for the job type where we can put functions to resolve the fields of a job. And the field we need to resolve is company. But how can we return the right company from this function? Well, what you need to know is that each resolver function receives some arguments, and the first argument is the parent object. In this case, since we are resolving the company for a job, the parent object is the job. Given this job, we want to return the associated company, so we can call db.companies.get, and here we need to pass the ID of the company we're interested in. And that ID is job.companyID. So we're saying return the company whose ID is the same as the company ID of this job. That's why these functions are called resolvers. This function resolves a company for a given job. Note that the job object we have here has a company ID property because that's an object coming from the database. The job object passed to the company resolver function is the result of invoking the parent resolver in the hierarchy. You can think that when the client sends a query that says, "Give me the jobs," the GraphQL engine first invokes the jobs resolver for the query type, and this returns an array of job objects from the database. At this point, the GraphQL engine goes through each job in the array and invokes the company resolver for the job type. Now we need to remember to include this new job object into the object exported by this module, otherwise it won't actually be used. Let's save this file and go and test it. If we run exactly the same query as before, you can see that this time the company fields are not null anymore. They are objects with IDs and names. Let's do another test. Let's try requesting the company description as well, and maybe the job description too. Execute again, and we get a lot more data in the response. Right, let's do a quick recap of what we learned in this video. Starting from the schema, we added a company field to the job type, that is of type company. So we now have two custom types with one referencing the other. And in the resolvers, we have a new function that knows how to return the company for each job. In the previous video, we added the company field to the job type, and we wrote the resolver function to fetch the company for a given job. We tested the query in GraphQL, and we get an array of jobs with all these fields. That means we should now have all the data we need for this job board screen. So it's time to switch to our client project in the editor and call the GraphQL server from the front end. Just to remind ourselves of how this works, app.js is the entry component, and it uses React Router mapping the route path to the job board component that's in this file. At the moment, this component gets the jobs data from the fake-data.js file, so our task is to stop using this fake data and instead fetch the data from our GraphQL server. Let's start by creating a new file where we'll keep all the GraphQL requests. Let's call it requests.js. Here we can write a function, say load jobs, that will call the server and fetch the jobs data. We're going to use the same approach we took in our first example, that is, use the fetch API to make a regular HTTP request. I'll declare the endpoint URL at the top so it's easier to change if we need to. We run our server at http localhost port 9000/GraphQL, so that's the URL we pass to the fetch function. Then we need to pass some request options. The method should be post. We need a header for the content type. That should be application JSON. And finally, we need a body that is a JSON object with a query property that contains our GraphQL query string. The query will be the same one we tested in GraphQL, so let's go and copy it from there. Actually, we don't need all these fields. If we look at our job board, you can see that each row in the list only has the job title and the company name. So we don't need the descriptions in this query. We don't want to overfetch data. This is enough for the job list. Let's copy the query string and go and paste it into our load jobs function. There you go. Next, we get a response from fetch that is asynchronous, so let's declare this function as async, and then we can await the response and assign it to a local variable. Okay, the next step is to get the response body by parsing the response as JSON. And finally, we want to return a value. If you look at the GraphQL response, it has a data property and inside it a jobs property. So in our code, we can return response body.data.jobs. That's it. Now we can export this function so we can use it from other files. And in jobboard.js, we can remove the fake data and import our new load jobs function from requests. At this point, we want to make this component stateful because we'll keep the jobs data in the state. So we add a constructor, we take the props and pass them to the parent constructor as required by React. We can then initialize the state where we keep the jobs data. We can set it to be an empty array initially. We do need to set an initial value because fetching the data from the server is asynchronous, so for a usually very short amount of time, our component will be displayed before the data from the server has been loaded. By using an empty array, we'll just show an empty list on the page. Now, in our render method, we can extract the jobs data from the component state, and we're already using the jobs variable here as the data passed to the job list component, so we don't need to change anything else in this method. What we still need to do, of course, is load the data from the server. And the best place to do that is in the component did mount method. Component did mount is one of the lifecycle methods of React components. As the name suggests, it will be called when the component has been mounted, which means effectively when it's displayed on the page. So here we want to call our load jobs function, and this returns a promise, so I'm going to declare this method as async. This way we can get the jobs data by awaiting the load jobs response. Finally, we can update the component state with the jobs data we just obtained from the server. So when the response has been received from the server, this component will re-render and display the new data. Let's save this file and see if it works. Open our job board. You can see that this page looks a bit different now. It's showing the jobs data that comes from the server. That means it ran the GraphQL query successfully. Good stuff. Now, if we click on an individual job, that doesn't work, and that's simply because we haven't updated the job detail component yet. It's trying to find a job with the ID coming from the server, but it's still using the fake data hard-coded in the client. That's why the job variable is undefined. We'll fix that as our next task. Let's quickly review what we've done so far. We modified the job board component to fetch the jobs data from the server. And in the requests file, we wrote this function that sends the GraphQL query as an HTTP request. In the previous step, we updated this job board component so that it fetches its data from our server using this load jobs function. And that function is defined in the requests.js file. It uses fetch to make an HTTP request with a GraphQL query. So the jobs we see in the front end now use the data from the server returned from the GraphQL endpoint. However, if we try opening the details for a particular job, we get an error. That's because the job ID in the URL comes from the server, but the job detail component is still using the fake data hard-coded in the client. So let's go and fix this. If we look at the routes in app.js, we can find one for the path /jobs/jobid. And this corresponds to the job detail component, which is this file. As we mentioned, this component still uses the jobs data in the fake data file, so when it tries to find a job with the ID returned by the server, it won't find any, and that's what's causing the error. Let's go back to our code. So in this component, we want to fetch the job data from the server, but before we can do that, we need to update the server first. Let's switch to that project. At the moment, the only query we can make according to this schema is to get all the jobs. What we want to do is add a new field to the query type to get a single job. However, we need to specify which job. We don't want just any job, we want the one with a specific ID. In GraphQL, we can pass arguments to a query using this syntax. Inside parentheses, we put the argument name like ID, and then we declare its type, that in this case is ID. We can also add an exclamation mark to say that this argument cannot be null. It's not possible to get a job without passing an ID. Finally, outside parentheses, we declare the return type of this field, and what we want back is a job. So that's how you define a query with arguments. You can see that it's pretty similar to writing a function in JavaScript. Next, we'll need to write a resolver for our new query field. Let's add it inside the query object together with jobs. Job is a function, but this time we pass some GraphQL arguments. How do we access them from a resolver? The first argument to a resolver function is the parent value, that in this case is the root object. We used the first argument when we wrote the resolver for the company field in the job type. In that case, the parent is the job for which we want to resolve the company. Here, however, we're inside the query type, that is the root object. That's why I called the parameter root. We're not actually going to use this parameter anyway. What we're really interested in is the second parameter, that is args. This will contain the arguments passed in the GraphQL query. Next, we need to return something from this function, where that something is a job from the jobs collection in the DB. We want to get the one with the ID passed in the arguments, i.e. args.id. That should be it. Let's save this file and go and test it. In our graphical tool, I'm going to delete everything first and reload the page to refresh the schema. Now we can write a new query and we can select job from the field list. We can pass an argument by opening parentheses, write the argument name, that is ID, then colon and a value. Here we need a valid job ID. So I'm going to copy the one we were trying to look at in the front end, and I'll paste it into the query. Note that in a GraphQL query, strings must be enclosed in double quotes. You cannot use single quotes like in JavaScript. Next, this returns a job object, so we need to specify which fields we want. Let's pick the ID and the title for now. Let's run this query, and that's the result. We get a single job object with title Frontend Developer. That's good. Our resolver is working fine. We could actually simplify this code slightly, since we know that the args object contains an ID. We could use object destructuring to extract the ID directly here, and then just pass ID to db.jobs.get. I like it better this way because you can look at the resolver function and immediately see that it expects an ID in the arguments. Let's quickly test it again, run the same query, and we get the same result. Great! So that's it for this video. We updated our schema, adding the ability to fetch a job by its ID. And in the process, we've seen how to accept an argument in the schema definition, how to handle it in the resolver function, and also how to pass the argument when writing a query. We updated our schema so we can get a job by its ID. We implemented the resolver function to get the right job from the database. And we can see it working by running a query from GraphQL. Our next step is to update the front end so that we can see the details for a job, something that's currently broken. We need to call the GraphQL server and get the data for the job with the ID that's in the URL. Let's go back to our editor and to the client project. Here we have the job detail component that's currently using the fake jobs data. Just like we did for getting the list of jobs, we want a new function that makes a GraphQL request to retrieve a single job. The code is going to be very similar to the load jobs function. So let's start by just copying and modifying this function. We can call the new one load job because we'll return a single job, and we'll need to pass the ID of the job we want. Most of the request will stay the same. We call the same endpoint URL, and it's still a post request with a JSON body. But the query string will be different. We already wrote the query to get a job in the graphical tool. However, we need to tweak it a little bit. For the job detail screen, we want not just ID and title, but also the company with its ID and its name. And then we want the job description. Let's try running it. That's good. The other thing about this query is that we need to pass the job ID as an argument. So from our JavaScript code, we cannot send this exact query string with a hard-coded job ID. We need to somehow insert the right job ID into the query. Maybe we could use a template literal string or something like that in JavaScript to do the variable substitution, but actually GraphQL provides a way to pass dynamic variables directly into the query. If you remember, we mentioned at some point that we can explicitly write query at the beginning. This is actually required if we want to use variables. We can also give an optional name to our query. For example, we could call this one job query. This is also called the operation name. It doesn't really make a difference in terms of what we get back as a result, but naming the query can be useful, for example, for debugging. If there's an error, the operation name will be logged as part of the error message, and this can make it easier to find exactly what caused the problem. So it's usually a good idea to set a name for each operation in production code anyway, but what we're really interested in right now is passing variables. We can now add parentheses and declare a variable, like $ID. Note that variables must start with a $. Then we specify its type, that should be ID exclamation mark. The type here depends on how we're going to use this variable. In this case, we want to use it for the job ID that is defined as a non-null ID in the schema. So the variable must be of the same type. Once we have declared a variable, we can use it in place of a value. So instead of this string, we can pass $ID. This way we removed the hard-coded ID from our query, but now how do we pass the value? Well, that's what this Query Variables panel at the bottom is for. Variable values are sent as a separate JSON object. In this case, the only variable accepted by our query is ID, and note that here the variable name does not begin with a $sign. It's a bit strange, but the $sign before variable names must be used only inside the query. Anyway, here we need a valid job ID, so I'll copy the one from the response. If you run this query, we get back exactly the same result. But in this way, if we want a different job, we could pass a different ID in the variables object without touching the query string at all. So this is the query string we want to use in our code. Let's go and copy there, replacing the old value. Now we need to think about the query variable. We need to set this ID to be the ID passed to this function. And the way to do this is to send another property in the JSON object called variables, that is an object containing the ID. We're using the shorthand syntax here to set both the property name and its value. At this point, we just need to extract the data we're interested in from the response body. If we look at the response object, we want the job property inside data. So we just need to change jobs to a singular job. That's it. Now we can go and use this function in the job detail component. First, we need to replace the fake data import with one for our new load job function that's exported by the requests module. Then we can call our new function, but before we do that, we need to modify the initial state as well, because we don't have the jobs here anymore. This came from the fake data. Before we load the data, we can set job to be null initially. Now, this may cause a problem if React tries to render this component when job is null. Trying to access the job title, for example, will result in an error. As a quick fix, we can check if job is not set, then just return null. Returning null here tells React not to display anything, so we won't display the job details component until we actually have the job data. At this point, we can actually load the data from the server, and we'll do that in the component didMount lifecycle method that I've also declared as async, so we can use await. So here we call our new load job function, and as argument we should pass the ID of the job to be loaded. We do have a job ID variable defined, but it's currently in the constructor. So let's move it to the component didMount method, and now we can get the load job result, that is a job. And we need to await it because this function returns a promise. Finally, we can call setState and update the job data. Updating the state will trigger a re-rendering and the component should display the new data. I think that's all we need, so let's go and see if it works. You can already see here that the page has updated and we are seeing the job details for a front-end developer. Let's start from the home page again. Click on a job and we see the details for a different job. This is for a backend developer. If we click home again and select the third job, this is for a full stack developer and for a different company as well. So that's great. Now let's have a quick look at the HTTP request. So with the network tool open, I'll go to home and then open another job details. And now we can select the last GraphQL request. If we look at the request headers and scroll down to see the request payload, you can see that in addition to a query string, we're now sending a variables object. So that's how we send query variables in the JSON request. Pretty simple. Let's just do a final recap. We changed the job detail component so it loads the job data from the server using the load job function that's very similar to the previous HTTP request we wrote, except that we're accepting a parameter that will be passed as a GraphQL query variable. Our next task will be to update the company detail component. That's the one we see if we click on the company name in the job detail. It currently gives an error just like the job detail did before our latest changes, so we'll have to fix it.